Last section of this chapter, 8.6b, solve more rational equations. All right, so last time we had rational expressions that were simply a proportion, where we could just cross multiply and be done. Well, in this case, we're going to have rational equations that have fractions that are added to each other or subtracted, and so it's not quite as neat. So here's the trick. Here's the bottom line. Multiply every term in your equation by the LCD to eliminate the denominators. That's the trick. You may have already done this before, and if so, then awesome, great. If not, here we go. So if you multiply everything in the entire equation, everything in both sides, then you have changed nothing. You've kept the equation equivalent. Remember, do the same thing to both sides. So we can multiply by anything we want, as long as we do it to everything in the entire equation. Now, if we do that by the LCD of all of the fractions involved, then we eliminate all of the denominators. Let me show you. So if you've got the denominators x, 4, and x, your LCD is going to be 4x, right? Because you got a 4, you got an x. If you multiply every part of this equation by 4x, then you can see, in this case, the x's are going to be eliminated and you have 20. In this case, the 4's are going to be eliminated and you have 7x. And in this case, the x's are eliminated and you have negative 36. Ta-da! All right, so let's just subtract 20 from both sides. So 7x equals negative 56. Divide by 7. So x equals negative 8. Done. All right. So once you've eliminated those denominators, then it's just a quick, easy equation. That's why I went fast through that. You know how to solve equations by now, or you should. All right. So don't forget, always to go back and look. Negative 8 is x, and that's not 0, so we're good to go. And don't get complacent with that, because as soon as you stop checking, there's going to be one that won't work. All right, so let's keep going. Let's see. We've got one. Now remember, if you've got just a whole number, that's the number over 1. So its denominator is 1. So the LCD here is going to be 1, which doesn't matter. We've got x minus 5 and x. So your LCD is x times x minus 5. All right, and remember that this x isn't the same as this x. That's not a factor. This is a whole binomial. So you can't just take out a part of a binomial and call that part of your LCD. You've got to actually multiply both parts. Okay? So remember, don't forget the whole number. Just because it doesn't have a denominator doesn't mean it doesn't count. All right? That's one of the terms. So you've got to multiply this term by the whole x times x minus 5. This whole term by x times x minus 5. And this whole term by x times x minus 5. All right? In this case, you're just multiplying by 1 and nothing gets to cancel out. So you have the whole x, and what I'm going to do is I'm just going to go ahead and multiply it out. So you've got x squared minus 5x. And then this whole x minus 5 will cancel. So you just have 8x, don't forget it's negative, minus 8x. Equals, in this case, the x's are going to cancel out. So the 3 gets distributed through the whole x minus 5. So you have 3x minus 15. Okay, did you see I did 2 steps in 1? All right, you can do this. So make sure that you multiply through your whole binomial in this case. All right, let's combine some like terms. We've got x squared minus 8, 9, 11, 12, 13, x. Actually, let's bring this stuff over also. So minus 3x is going to make this 13, 14, 15, 16x minus 16x. And then minus 15 equals 0. The reason, you know, right? Hopefully. The reason I brought it all over to one side is in order to solve for a trinomial, you've got to have everything equal to 0, and then you solve, you factor it out. So we're going to factor x times x is x squared. Negative 15, so it's negative, so you've got a plus and a minus. You want your bigger one to be negative. Let's see, you can't do 15 and 1 because 15, oh, did I do something wrong? You can't do, oh yeah, you can do 15. Nope, because that would be, oh, you know what I did? guess what? I was like, why is this not working? Because we add the 15 to both sides. This 15 needs to be positive. Ha ha! Which means that my signs need to be the same, and which also means that this will factor. Oh, good. So the signs need to be the same, and the signs are both negative. And you knew that all along, didn't you? You were hollering at me, wait, that's supposed to be positive. You got to move it over. You got to change the sign. All right, so now we've got 15 times 1 is 15, and 1 plus 15 is 16. All of that equals 0. So then remember, if you've got two binomials multiplied together equal to 0, one or the other of them has to equal 0. So you're going to set x minus 15 equal to 0 and x minus 1 equal to 0. Solve for both of those. So x equals 15 or x equals 1, because you add 15 to both sides and make it positive, add 1 to both sides and make it positive. So then we go back in and check, because I keep telling you to do this, check for the extraneous. And 15 minus 5 is 10, and 15 here is 15, so that's not a problem. 1 minus 5 is negative 4, that's not 0, and 1 is not 0. So once again, we don't have to worry about extraneous in this one, but don't get complacent. All right, let me make sure that you've got enough space that we can see, probably, but you know, just to make you dizzy and just to make you laugh because I'm chopping off my own head. All right, so on these, you've got x minus 3, x squared minus 9, and x plus 3. In order to find out what the LCD is, remember, you've got to have the factors of each of these. So you need to factor. This is not all the way down to its lowest factors. So you've got to factor that. And this is a perfect square minus a perfect square. So x plus 3, x minus 3. And lo and behold, haha, we've got x minus 3 and x plus 3. So our LCD is x plus 3, x minus 3. So each part is going to be multiplied by x minus 3, x plus 3. This whole thing by x minus 3, x plus 3. This whole thing, x minus 3, x plus 3. So far, so good. So step 1, find that LCD. Step 2, make sure you multiply the LCD through every term in the entire equation. So now, are you getting to where you can do this on your own? Get ahead of me. See if you get the same answer as I do. So now, cancel out your x minus 3's. And then you're going to have to multiply the 6 through, so you're going to have 6x plus 18. These will both cancel out and just leave you equals 8x squared. The x plus 3's are going to cancel, leaving you with just 4x times negative 3. So now be careful, this is negative. So be careful with your signs, because negative 4x times x is negative 4x squared, and then negative 4x times negative 3 is positive 12x. All right, just like before, those negatives will mess with you. All right, so combine some like terms here. What I'm going to do is let's combine these first and keep them on the right hand side, because I'm going to end up with 4x squared here, and that's positive. All right, so I'm going to subtract 6x from both sides to get my x's together. So I have plus 6x, and then I'm going to subtract my 18 from both sides, and that's going to equal 0. Just see how I did it? I took some shortcuts. I'm thinking that you can take some of those shortcuts now, as long as you don't miss some important parts. Okay, so factoring, let's factor a 2 out just to make our lives easier. 2x squared plus 3x minus 9. And then factoring 2x and x. Have you done this already ahead of me? Let's see. I'm going to put the negative here and the positive here, because I'm thinking that's going to be the biggest. 3 times 3 is 9. Let's try 3 and 3. 2 times 3 is 6. Minus 3 is 3x. So we're good to go there. So now when we're solving, this equals 0. Oh, all of it equals 0. So the 2 we know can't equal 0. So either this term equals 0 or this term equals 0. So when we solve this, add 3 to both sides and then divide by 2. So x equals 3 over 2 is one option. Subtract 3. I didn't say x plus 3 equals 0. Subtract 3 from both sides, so x equals negative 3. So there's my 2. possibilities, and then we're going to put those in. Oh, good. You can still see what I'm doing. We're going to put these options in. So 3 halves minus 3, that's not 0. 3 halves squared is going to be 9/4 minus 9. That's not 0. 3 halves plus 3 is not 0. So we're good to go on the 3 halves. Negative 3 minus 3 is negative 6. No problem. Negative 3 squared. 3 times 3 is 9. 9 minus 9 gives us 0 in this denominator. I don't even have to check that one because negative 3 makes this denominator equal to 0, which means this is an undefined fraction. So this is an extraneous solution. So negative 3 is not one of your solutions. 3 halves is the only possible solution for that equation. All right. Now, because you knew it was coming, and that can't possibly be all, I have, surprise, surprise, a word problem. All right, so in this case, we've got another company. Business uses these equations a lot. So we've got this company, and they produce computer desks, and they have determined that the model for the cost to make X number of computer desks is the equation that we have there. The cost function equals 4,000 plus 50x divided by X, where X is the number of desks that are produced. So what I want to know is how many desks do I need to make in order for me to average a cost of $85 per desk? As you increase and decrease the number of desks, that's going to change the average of the cost of the desk because of this 4,000 that we've added in. All right, the initial cost, the startup cost of their business or whatever, wherever that came from in their business. So, how many desks for an average cost of 85? The cost is 85. That's what we're going to put in. So the 85 equals, let's just put it in and solve it. 4,000 plus 50x divided by x. Now this is one you can either use, the method that we used today and the method we used in the last section, or the last video, are exactly the same, because in this case the common denominator is x, so you're going to multiply everything by x. Well, if you cross multiply, you end up with the same thing because this is 85 over 1. So you're just going to cross multiply and you'll get 85x equals 4,000 plus 50x. Subtract 50, yeah, just solve it. Go fast, you can probably beat me. Here we go. Minus 50x, 35x equals 4,000. Divide by 35. And because I've already done it, stick it in your calculator. 4,000 divided by 35. X is approximately 114 desks. That was an easy word problem. See, and you groaned. You shouldn't groan. Okay, so in this section, the important thing is make sure that you find the LCD of every fraction in that equation and then multiply every part, even if it's not a fraction, even if it's a whole number, every part of every term in your equation must be multiplied by the whole LCD. A lot of those will cancel out. That's the beauty of it. That's why we did it. Okay? So all of your denominators, if you do it right, all of the denominators should eliminate and you'll have an easy equation to solve. See you next time.